My Vectrix VX-1 is most definitely not back on the road yet, but guess what? I am now ready for the Transport Evolved production version of Dr. Horrible's sing-along blog. Ha 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 ha. Yes, folks, as I said in the introduction, my Vectrix VX-1 project bike is not back on the road yet. There's a Skye by my feet, so if you see a head pop up, it's probably her. She's a very cautious dog, and I'll make sure that she stays clear of any of the powerful electronics. I know I joked a little bit at the beginning about these, but I did have a pair of high voltage protective gloves from about 15 years ago. They're somewhere out there, and I decided that in order to safely work on this battery pack, I needed a new pair, so I went out and bought a pair today. And yes, of course I have a score of Dr. Horrible's sing-along blog. And Kate has been taking singing lessons, so maybe I can convince everybody on the team to do that for a holiday special. Let us know in the down below. No, actually, don't. I don't think we can afford to make such a video at such short notice. But anyway, let's talk about these batteries and our VX-1 project. And in our last video, I was outside and I showed you these batteries very briefly and explained a little bit about what I wanted to do and how I wanted to integrate it all in. But let's give you an update. Since that last video, I have ordered both of the chargers for the bike. They are due today or possibly tomorrow, and when they arrive we might do an unboxing. If they arrive while we're filming, we'll throw the unboxing into this video. I should point out that this is only one half of the battery pack that's going into my VX-1. It's nowhere near the voltage that you would need to be capable of fast charging. Nominally, this battery pack's voltage is going to be about 144 volts. I would need it to be over 200 volts to use fast charging, and while some folks have been playing with Prius components to try and boost the voltage to give lower voltage electric motorcycles DC fast charging, that's not what I'm going to do with this project, because I am shooting for approximately 150 miles of real world range, and I'm probably going to need to stop for a couple of hours to let my bum recover if I ride a motorcycle for that long. I'm not riding around the world on my Vectrix, at least not yet. So to the cells. These are AESC cells. They were designed for a Nissan Leaf, for a 4th generation Nissan Leaf, and combined all of these 10 cells, the other 5 are off the camera, is hopefully going to give me somewhere between 12 and 15 kilowatt hours of usable energy. Now I say between because obviously these cells are a few years old, they are second hand. When they were brand new, they had about 15 kilowatt hours of nominal capacity. Even if they've degraded badly, which I don't think they have, I'm shooting for about 10 kilowatt hours to 12 kilowatt hours. Now 12 kilowatt hours is about 3 times what my Vectrix VX-1 had when it was brand new. So it's a win-win as far as I'm concerned. I bought these from a chap on eBay. I paid $2,000 or just under $2,000 for 10 of these modules, and each of these modules contains 4 individual groups of battery cells. Now the cells are arranged 2S, 2P. So for every pairing of these cell terminals, there are 2 cells in parallel, and then you have 2 cells in series. So there's 4 cells in each of these little compartments here. Normally, if you were building a Nissan Leaf based conversion for any vehicle, you would need to use the original bus bars that came with the Nissan Leaf and allow you to connect all of the cells together, to wire them together in series to give you the voltage you need. But these cells have never been in a Nissan Leaf, despite being Nissan Leaf cells. They came from a project from a company called FreeWire. Now, FreeWire has been around for a while. They specialize in battery-based charging solutions for EVs, and these days you might know them better. They had some financial woes last year, so I don't know if they're still around in the same kind of form that they were a couple of years ago. But they primarily focused on offering fast charging solutions for locations where the utility couldn't provide the full power that you would normally need to operate a fast charging station. And the idea was that these charging stations would have integrated battery packs in them, and the battery packs would slowly charge up when there wasn't anybody charging their vehicle. They would pull power from the grid, slowly charge up, and then when a customer came along to charge their car, it would use some power from the grid and then supplement that with power from batteries. Now, these didn't come from one of those static units, but instead came from a product that FreeWire did even earlier in its life cycle, and that was a portable charging unit that could follow someone around a parking lot and charge up people's EVs wherever they happen to be. These cells, as I understand it, haven't been used very much. They don't have very many cycles on them, and when I bought them, they were all hovering around empty. Now, empty for lithium ion cells like this, these are NCM cells, is somewhere around 3 to 3.2 volts. I had one set of cells, in fact it was module 2, so this one here, the cells in module 2 are actually just literally below 3 volts, like 2.98 or 2.99 volts, something like that. But I've been able to bring all of these battery modules back up to a modest state of charge, and now I'm ready to start assembling the cells, to put them together, to start building the battery pack. And for that, instead of using the standard Nissan Leaf bus bars, which come with an integrated protector to ensure you don't short circuit the battery by dropping something on top, which is why this has a bit of insulative tape on it, FreeWire actually commissioned these. They're multi-layer boards. They're capable of transferring 250 amps in a circuit. And they're really nice because not only does each of these have proper labeling and it sits on top of your battery like so, or rather like so, it also means that you can pull individual wires through this it's a Molex Microfit Junior, I think, is this particular type. I do have it written down somewhere. I had to look it up. Thanks to those in the Discord chat room at Transport Evolve for helping me track down this particular connector. But you can then pull these individual cell voltages out, which makes it super easy for me to attach a BMS. So I'm going to assemble this together now and show you what one half of the pack is going to look like. I'm going to explain how we're going to mechanically connect all of them, and then I'm going to talk to you a little bit about how I charged them, how I brought them back up to a safe-ish voltage, and then I'm going to talk about making these, because this has been my sole job for the last 3 days. So let's start with the actual battery pack and assembling the modules. Now, actually turned this around, so I need to put this back like that so it all aligns properly. On top of these battery modules, you'll see there's black and red. Obviously, black is negative, red is positive. And to put everything back together, I'm going to put one of these on. But before we do that, these cells need to be compressed. They need to be compressed gently, and that can help eliminate swelling as the cells charge and discharge. It's not something that is a major problem when you're using these in a motorbike, because you're not pulling high currents. Having said that, one of the local groups for Vectrix owners had somebody in it recently who had these, and he let them discharge, and then the cells expanded and bad things happened. So I picked up these online, threaded rods, and combined with these little furniture end caps, I'm going to be able to make a through rod that will mechanically compress the pack. Right now, they are a tad long, so I'm going to have to get out either a hacksaw or a Dremel and cut off about that much on each of these threaded rods to enable me to properly cinch it down. But let me show you, even though it's going to be slightly loose, I'm going to show you how it's going to work. So literally, these cells have holes at the top. There you go. And then I can put these through in each corner. Now, I should point out that these rods are going through, not through the actual cells themselves, but rather through the casing for the cells. And it means that you can make a nice rigid 5-module battery pack. Now, why am I not doing them as a group of 10? Well, I can't fit 10 in the bike in one go. 10 modules, fully compressed, just fit into this bike, and so I'm gonna have to put them in groups of 5. Thanks to, I can't remember who it was, someone online who told me about these end caps as a good way of allowing for compression without taking up too much space, because without them, it would be very difficult indeed to properly compress these. And you can see by how much, if I push this one through, you can see by how much, like almost less than a thumb width, that I need to cut off the rod to make sure that it will fit. So I'm going to carry on putting these in, taking my nice expensive high voltage gloves and throwing them on the floor. Now, I've written down somewhere all of the torque settings that I need for compression for the battery pack to make sure that everything is safe, and I'll probably write them down somewhere on a web page. We'll probably make a web page. We're working on a new blog at Transport Evolved, and we'll be able to put things like this on it. So keep your eyes peeled for that. So I want you to use your imagination at this point and imagine that I have actually cut these rods to length and we've been able to properly tighten everything up. But you'll also note that across here, we've got these little posts. They're not very strong, but they're strong enough to support the battery when the battery is being lifted into and out of the bike. But in order to make things even more safe, we have picked up some flat aluminium or aluminum. So we're going to cut this aluminium into lengths. It's about 13.5 inches from corner to corner. And once we've done that, we are going to drill holes in it. This is a special metal drill bit that I purchased specifically for this project because I live with a woodworker and she's got lots of amazing tools and she's got lots of amazing drill bits, but it is more than my marriage is worth to use a wood drill bit make these holes anyway. So once we've done that, we will have this aluminium piece or aluminum piece on here that will slot over the top of these rods. I can show you on the front if you want, so you can see it will go over like that. And then when we want to lift this into the bike, we can run some very strong straps through and drop it into the bike safely. Now, before we actually put it in the bike, I want to be clear that we're not going to have these boards on, because these boards are kind of not fragile, but I only have 10 of them. So if one of these boards was to be, damaged by the process of me putting it in the bike, I would be very upset. Similarly for these bus bars, these metal bus bars. So I'll take all of these off, and then we'll pop the battery in after we first electrically insulate all of these connectors, or all of these posts here. We'll put electrical tape over them to make sure that none of the fussing around as we're putting the battery in will cause a short. And talking of which, let's put on my gloves. Yes, that just made a fart noise, but you're supposed to do that with electrical gloves. You're supposed to check to make sure there are no holes in them. All right, so while this half of the pack is only, I think currently it's about 74-ish volts. When everything is fully charged and everything is connected, it'll be over 150, 160 volts. And so having these gloves is really important. I'm going to put this on, and I'm going to follow proper practice, and I'm going to put this all together so that you can see how it works. So we literally line up the board. We line up the holes. I mean, these gloves don't stop you from shorting things out, but they stop you from getting an electric shock if things go wrong. And of course, you don't electrocute yourself, because that implies that you've died, I think. Have I got that right? I think that's how it works. Anyway, or not works. So these are just M6 bolts that go in here, just so that you can see kind of the orientation here. So this is a negative terminal, and this is a positive terminal. So the electricity goes all the way through. In the middle here are the center posts. So this is a negative, this is a positive that's connected to this cell. So for this cell, it's a negative connection, that's a positive. That is bridged across, and then it repeats over onto this side. Now, if these were going in a conventional arrangement, very often you would need to put a wire here and a wire to every one of these, so that you would have a way of operating your battery management system, a way of making sure that the batteries were healthy, a way of making sure that everything was working as it should. Because I have these fancy boards, I literally just have to screw these in and torque them down to the appropriate values. I have a bit of a cheat sheet here. I think these are 1.5 Newton meters, and then these have to be down to 5.5 Newton meters. So not very heavily torqued. And of course, these boards have a little bit of give in them, so you want to make sure that you don't over torque it, because you don't want to crack the traces in this board. It's a multi-layer board, and it's a multi-layer board that's rated to carry 250 amps. So we want to make sure we do it properly, and we take our time, and we don't screw up. So next, we'll put this one on. And while I have only very, very loosely connected these together, I'm just going to use my socket here, or my wrench, depending on which side of the Atlantic you are. And I'm going to make sure that I don't short that out. And I'm just doing it kind of not finger tight, but just a little bit more than finger tight. All right, now I can get my voltmeter out, and kind of embarrassingly, my voltmeters are all needing new batteries. So I actually got out my fancy mains current clamp, but it has a voltmeter in it, and it's auto ranging. So let's see. So negative and positive, and it should be about 74 volts. 73.9 volts. And if I go through, each of these should be like 3.69, 3.7 volts, something like that, which they are, which indicates that the pack is very, very evenly balanced throughout, and I don't have any weak cells. How did I know the pack was going to be okay? Well, the guy I bought these from said that he had, when he took them out of the packs and disconnected all of the modules, they all had voltages around 3.5 volts, which is just totally fine. They have been sat for a while, so they did discharge lower, but let me show you how I have been charging them up. And when I first got these cells, what I did was I actually put wires across each of the cells in turn, and slowly, using this power supply, which is capable of up to 120 volts, but also you can adjust it to a very low voltage. I used basically about 1 amp to charge each of these cells individually over the course of about 2 weeks to within like 3.3 volt-ish range. Once each of the blocks of 5 were all about 3.5 volts each, 3.3, 3.5 volts. I then connected all of them in series. So positive to positive. And then I'm actually going to turn this on, otherwise it will spark. Negative to negative. And then you can see there, it's actually the voltage that it should be. It is capable of constant current and constant voltage. So if there is a big discrepancy between the pack voltage and the power here, the voltage here, you'll get the constant current. So I'll put a very constant current through to bring the voltage up. And then when it gets pretty close, it will switch to constant voltage and slowly ramp down the current until you get to, well, what you can see now. This is charged as far as this is concerned. If you're watching at home and going, but that's not fully charged based on the maths for these, you'd be right. These cells right now are maybe 40, maybe 50% full, and I don't want to charge them up anymore until they're in the bike, and I don't want to charge them up anymore until they're properly compressed, until I've got that rod on. And so for now, these are in the keep them safe voltage range. So no physical damage can happen to the cells, and nothing bad, fingers crossed, is going to happen to any of this. So that's how we did this all. Let me turn this back off. We'll wait for the voltage to drop. Give it a few seconds because it's got some capacitors in it, and then I can disconnect it and we can go on from there. And I can take these off now. So given that this has got large amounts of power going through it, how am I going to ensure that this stays safe in the bike? Well, as I said earlier, the Nissan Leaf normally has special interconnects, bus bars. Couldn't get them off. That would have been embarrassing. Special bus bars that have a protector built into them if you buy one from a Nissan Leaf, but we didn't. And so I decided to break out my 3D printer. I decided what I needed to do was to make a protector that would fit over the top of the batteries, like so, each module, and not only provide isolation for each of these terminals to make sure that nothing could be dropped over and short out, but also to look better. And so over last weekend, I started working on a series of iterative designs. So these two are my first attempts. I had never used Fusion 360 before. This is my first attempt at making a 3D model and then printing it out on my Bamboo X1 carbon. But the finished one, I know it doesn't look quite finished yet, but dimensionally this is pretty close. I may have a few tweaks to go. I can probably take these off now. But dimensionally, they go on like so. And the idea is that these will fit on the battery like so. That one is not a very good example because that's an earlier prototype. So let me find a prototype that does work. There you go. The idea is that these will eventually be printed out in ABS, in orange ABS, because I shared this with Discord and on social media, and many people are like, it needs to be orange. So I'm printing this out in orange ABS plastic, which I had to buy, I want you to know. And then what we will do is each one of these will bolt onto the top of the battery. It will be an orange case with black writing. But if we go to the kind of the very first examples, you'll see here, I had some very hollow ideas about the construction and very flimsy walls that, you know, very easily break. If we go to one of the most recent examples, this one actually has a little issue here. I accidentally moved this wall too far that way, so this one has got it pulled back again. But you can see I've got proper interconnect spaces here, or rather proper step spaces for each of the bolts. We've got the interconnect tunnel, which you'll see here. The interconnect tunnel is designed to prevent anything from hitting the bus bar. Of course, the bus bar can still be hit from underneath, but that shouldn't be an issue because it's going to be in my bike. And on top of this is going to be the what I want to call a gear tunnel. It's obviously not a gear tunnel, it's just a cover that fits over the battery pack. But ABS is known for not being great in sunlight. It can degrade in ultraviolet light, but I don't have to worry about that because this is going to be covered by something else. And orange filament was only available in ABS. I couldn't find any in PETG or ASA without going on a massively long hunt for it. So I was like, you know what? It was either going to be ASA, it was going to either be ASA, PETG or ABS. I picked ABS. I don't like printing in ABS. This, by the way, is PLA because PLA is one of the easiest filaments to prototype in. It's very forgiving. You can print really quickly and screw things up, and it doesn't screw up your printer. But that is what I'm going to do. So in the next couple of days, when the filament arrives, I'm going to start printing these out. Printing something like this out only took me like an hour. When you get down to this end and you've got thicker walls and you're trying to print in higher quality for the structural elements here, I mean, you can see it's pretty strong. This took a couple of hours, and to print this properly in the real material that I'm going to use, so it's going to be black lettering and orange case, it's going to take me about 5 to 10 hours depending on the print settings I use. I need to make 10 of them, and then I may actually put a sticker on to actually denote which of the modules. So at the moment this is 1, 2, 3, 4, 5. They've got them written on them in Sharpie. That wasn't me, it was the original folks who put the battery packs together for FreeWire. I'm going to keep the same numbering convention, and then I need to make this custom loom that will plug in to each of these. So each of these cells will have something I can, you know, plug the BMS into without going anywhere near this. And that rod I showed you will fit actually between the gap between the actual top of the case and the bottom of this. And for that reason, we actually are going to shave a little bit off in Fusion 360 to make this a little bit thinner so that the rod can fit underneath. It's aluminium, so it should be okay from an electrical point of view. And there's a nice gap. There's like a finger width gap between the bottom of the board and the actual case. So I'm good with that. Rapid prototyping these over the course of a weekend taught me so much, A, about myself, and B, about 3D prototyping and how fun it is. You can see this is version 3.75. I actually realized that if I print in white, I can write on it in a Sharpie. So this was from a point where I was like, okay, I'm going to make this design. It's all going to be great. It fits great mechanically. And then I went, oh, I can't bolt it down because this actually ends where the top of the posts end. So you can see here, I made myself a little note, delete some of this. I use like a woodworking sign, remove this bit, and then I've put here like pull this down by 2mm, pull this in by 2mm, because this is actually very thin, and I realized I can make it a little bit wider for more support. And then here, the adjustments that I can make to move things in. And right here, I thought this little connector was going to need a little tiny hole to allow it to sit slightly under the case, and I realized that's not actually required. It's probably not ideal because it could put extra mechanical strain on the connector and also on this. So I actually removed it. So on this one it says del for delete. This is version 3.5, which is actually slightly before this one. You'll see they're quite similar. This one again, I was actually making what I thought was a full pass-through at this point, but I hadn't made this little tunnel to allow the interconnects to be protected. So at this point in my design, what this little setup did was it just passed the bus bars out the bottom, not properly protecting them, which is where this design comes from and where this design comes from. If you've never used Fusion 360, but you have a 3D printer, give yourself a project. The only thing I would say is it's a very powerful program. It's very easy to make mistakes, but it has a feature that allows you to roll back through the timeline and correct mistakes as you go. The other thing I would say, or the other two things, is sketch everything you want to make in a single 2D planar sketch. If you need to do another one for the other axis, go ahead and do it. And once you've done that sketch, modify things using the sketch, not using the 3D extrusions. I didn't when I was doing this, and I got myself in a whole load of hurt for it. The other thing I would say is when it comes to things like fillets, don't do it until everything else is perfect. Yesterday I spent about 4 hours. I think it was this design, or possibly, no, it was this design, had some issues. And I went back, and because I had filleted everything and I'd done them individually, my timeline was a mess and I couldn't figure out what I needed to do and where I needed to go. I ended up breaking the model completely and had to go back to a previous version that I'd saved on Sunday night. So take your time, be gentle. Know that you will make mistakes. Print in a material that you know you can easily print, is not going to be super costly. And if you can print prototypes using materials that you can write on, this is a green Sharpie and this is a red Sharpie. It makes it so much easier when it comes to going back to your desk and tweaking the design. So I am actually in the process of, I've put this all up on GitHub, and I am going to be sharing this design, because even if you don't have these interconnect boards, you could still use this for a traditional Nissan Leaf module. You'd have to make some modifications, and I'm not looking for any kind of financial benefit from this. This is just something I made up because I want my batteries to be safe, and I want to be safe when I'm working on my batteries. So with this on, I cannot drop anything on here. I am clumsy, I know myself. And so once these are torqued up, I have a torque wrench that is appropriate for all of these settings. Once this is torqued up, I know that I can put this cap on and it will be protected. I know that this will prevent stink bugs from getting inside. Sure, stink bugs can get into this bit, but they can't get to the rest of the module, which again is a very good thing indeed. Also, if you don't have one of these and you are into 3D modeling, get one and learn how to use it. This caliper saved me so many times when I was modeling. Yes, I made lots of mistakes. I mean, you can see there's like maybe a dozen different versions of this, and I'm now at like version 4.5, I think is the latest version. And every time I make a major milestone, I'll put the revision up a little bit. But even though I printed all of these and every one of these was wrong in some way or another, I was able to get closer and closer and closer to the final design because I had one of these. I was able to measure exactly how far off I am. And I also learned that all of these are slightly different. So some of these posts are not exactly located where they are on others. And some of these boards, because they're small production, small scale, some of them are dimensionally ever so different. And so I needed to build those tolerances into my designs to make everything happy. So that's everything I've been up to with the bike. The charger and everything is coming soon. I have just got my new 200 amp main fuse. The Vectrix VX-1 originally had a 125 amp main fuse. This is the fuse that sits between the battery pack and the controllers on the bike, and this will blow if you pull too high a current to protect the electronics in the motor controller circuit. But actually, after a few years of production, the folks at Vectrix realized that 125 amps was a little bit too cautious, and actually 200 amps was closer to the mark. And I apparently have one of the few VX1s that's never been upgraded to 200 amps. So I have now, after consulting with the gurus of the Vectrix VX1 world, I have ordered this, which is a much cheaper replacement than this. I can still get this with a 200 amp variant, but I was quoted $400 for it. I picked this up for $50. So I will link to the part number if you happen to be a Vectrix owner in the down below. Spec-wise, it is a direct compatible unit. It drops in. I'll hold them side by side so you can see. They are compatible, and that means that that this one is the smart choice. So once that's done, once the battery packs are in, I have another modeling project to do, which I cannot talk about yet. We have a sponsor for the Vectrix VX1. I am so excited about that, and it is going to be a sponsorship, and it is going to be an affiliate link. I know we've stayed away from those, but it is a product that I have wanted to work with for a long time. It is a motorcycle based product. I know other people who speak incredibly highly of this company, and I will need to fabricate a special thing for my VX1 in order to make that happen. Now I can weld. I can weld like your strange aunt who only brings you burnt cookies can cook. So I'm not going to weld this component, but I am going to use my newly acquired Fusion 360 skills to model it, to print it out in PLA, to fit it to my bike, to test it. And once I have a model that I'm happy with, I'm going to probably use a service like Send Cut Send, or maybe find a local fab shop who I can give the model to and say, can you make this in metal? And if it doesn't work, then I'll go back to the drawing board and start again. Such is the benefits of 3D printing. Thanks for joining us today, and if you've got thoughts, make sure you leave them in our Discord room, on our Patreon page, down below, or you can reach out to us on Mastodon or Blue Sky. Thanks to the amazing list of people scrolling by on your screen right now. They are part of the massive community of supporters who make this channel possible, helping us through Patreon and YouTube, helping us cover our bills, pay our team, and ensure that we remain 100% independent. If you'd like to join them and see your name listed here, just follow the links below. We've got options across a wide range of different price points from just $1.50 US per month. A massive welcome to our newest supporters: Dan Fitzsimmons, Yanni Mavro-Philippos, MB, Bruce McKean, Nitmir, Calvin Klein, Marek Kowalski, Dave Nelson, Chip Chandler, Ed Zavada, Alan Bassel, Tully, Ronald Blackman, Christian Ranson, Michelle Brennan, Scott Weber, Dal Same, Bob, Harry Lamb, Jeff Curtis, William Radke, SDS, Barry T, Shitkrat Chowdhury, Ernest Bruce, Matthew, Bill, and Sphinx Garden. To join the list and get your shout out, become a paid Patreon member for your moment of fame, and you can even gift membership to someone else. If you'd like to support us with a one-off donation, you'll find links below to make Ko-fi and Bitcoin donations, and we even have an old-fashioned PO box you can reach us at for the time being, address listed below. You'll also find links to our swag store, and if you have someone who shops on Amazon, please consider asking them to use our affiliate link so we get the commission rather rather than Jeff Bezos. So we can continue to focus on making our content even better and reduce creator burnout. We are being a little freer with our release days, but we plan on dropping new content every Tuesday, Thursday and Saturday on our main channel, plus something on Sunday over on Transport Evolved Take 2. If you want more, the mighty algorithm that hates us thinks you should be watching this video, but this video is one that we think you should check out. Be awesome, be kind, be intentional, and don't forget to resist. Keep evolving!